through this one and explain to you what the only thing that's different is. The only thing that's different here, you're going to graph 2x minus 5y equals 10, and you're going to use a solid line because it's equal to or less than, and you're going to graph x plus 2y equals 8. And again, it's going to be a solid line. But what's different here is you're restricting x to being positive numbers. And y is also positive numbers or 0. So you don't even need to draw a grid in the middle. What you need to do is only include your first quadrant. So there's no point in even drawing the rest of them. The only quadrant where both x and y are 0 or positive is the first one. So by restricting my graph to this quadrant, I've taken care of those last two inequalities. And now I only have to worry about the other two. So let's see, for 2x minus 5y equals 10. If y is 0, x is 5. And if x is 0, y is negative 2. That didn't help me much. Slide it up.
Slow down.
Slow down, okay. So knowing my y-intercept here didn't help me much because I didn't leave it on my graph. But I can still use the fact that this is -1, -2 to draw the line, which is all I really needed to do. So my line needs to go like this. It would continue on down here, but this part is not going to be part of my feasible region because it's where x is below 0 and y is below 0 also. And then if I choose 0, 0 for my test point, which is my favorite point, it's true. So when I shade that part, I'm going to shade this way. Okay? And then I'm going to look at x plus 2y equals 8 and try to draw its graph. Let's see, if y is 0, x is equal to 8. And if x is 0, y is equal to 4. That would be this line. And the line does go on, but I don't care about anything except the part that's within this quadrant. So I can still test my favorite point because it's not on the line. 0 plus 2 times 0 is equal to or less than 8. And 0 is, in fact, equal to or less than 8. So I'm going to shade from that line toward 0. So it turns out that my feasible region is only this part right here. And my feasible region is called a bounded feasible region because it has solid lines on all of its sides. So that's called a bounded feasible region. Every single solution is contained inside that little quadrilateral. Now, if my feasible region had been this region out here, which it could have been, if it had been this region out here, it would have been called an unbounded feasible region because it's bounded here, here, and here, but it wouldn't have been bounded in that direction. It would have kept on going in X and Y, getting larger and larger. So that would be called an unbounded feasible region. Okay? Now, I know I went a little quick on that one, but I want to let y'all take a short break before we try to do anything with 3.2 and 3.3. So let's take about 10 minutes. Get up, walk around, wake up. We'll wrap this up with a quick review of what we've seen so far. I don't expect you to, I will leave this in the recording so you can fill in the very last example, example 6, but I went ahead and did example 6 without asking y'all to do it with me because it's more important that you see the result than it is that you actually go through it because it's the same as what you've done before, but the outcome is not the same. So we did example 5, and we found that this was a bounded feasible region because it has a solid boundary on all four of its sides. Now, there may be more than 4 sides if there's more than four equations. So, as I explained, a feasible region is bounded because it's completely enclosed by its boundaries. The feasible region in examples 3 and 4 are unbounded, and we'll go back and look at those. So here was example 3, and this feasible region is unbounded because it's bounded here and here, but on these other borders out here it is not bounded. It continues to go on forever. And example 4, even though it's bounded even on 3 sides, it is still not bounded at the bottom. So it's also an unbounded feasible region. And that's going to be important as we get into the applications problems because sometimes an unbounded region will prevent you from optimizing depending on what you need to have, whether it's a maximum or a minimum. So the example that we're looking at now is the feasible region for the system negative 3x plus 4y is equal to or greater than 12 and x plus 3y is equal to or greater than 6. So what we do is we graph each one of the inequalities and choose the appropriate half plane. And the feasible region should be the region where all of those overlap, where all the different shading overlaps. What you're going to see is there's no feasible region for the system, and therefore no solution to the system. Now the way they show it to you is this way. Negative 3x plus 4y is equal to or less than 12 is the blue line. And our test point 0, 0 fails, so we shade in that direction. X plus 3y is equal to or greater than 6 is the red line. And it goes in this direction. And if we stopped there, we would have an unbounded feasible region where it's gray. But it doesn't stop there. It says that there is also the restriction that y has to be equal to or less than 1, which means that it has to be below that green line. Well, none of the feasible region is below the green line. So what happens, honestly, and I'll show you a different version of the picture, but it shows the same thing. Here's your solutions to negative 3x plus 4y is equal to or greater than 12, and they go above the line. But below the line, y equals 1. So there's a potential overlap. But then when you graph this one, x plus 3y equals 6, you also have to shade above that line, but you can only go up to the line y equals 1. So we've got this area, and there is no overlap. So there is no feasible region that satisfies all of the inequalities. So if you have no feasible region, don't say, oh my gosh, I've done something wrong. There may be no solution. Okay? Now we've got a manufacturing example here. And I think what I'm going to do is I'm going to walk you through the problem and let you fill in your notes kind of as we go along, because in the next section, I'm not sure we're going to have enough time to take the test. So the reason I told you, yeah, we're going to have to come on Halloween is I think y'all's test is going to be on Halloween night.
That's terrible.
You can't?
No, I mean, I have this ever with my kids and oh my God.
Okay, then let's do it this way. Let's go ahead and have class next week. Because I was afraid I might run into that, because I looked at all of the people that were in this class and thought, oh, some of them are parents, or if not, grandparents like me. And yet I don't think we're really going to be ready to take the test next class period. We're going to need some more time from tonight, and we've got an application plus 2 more sections. So let's do it this way. Let's have class next week. At the end of class, I will open the test.
So we wasn't going to have class next week?
No, we are going to have class next week. We were going to have the test next week, but I don't feel like we're going to be ready for the test next week. Is what I'm saying.
Over chapter 2?
It's over chapter 2 and 3.
I thought you were gonna give us the option to do it over 2, just 2, and then to do it over chapter 3 too. Am I lost here, or did she say that?
You can have the option if you want to do it that way. In that case, we'll have the test next week and then finish chapter 3.
Yeah, that's.
Let's do
Let's
that,
do
'cause I don't wanna mix
Do
2
that?
and 3 together, no. Like,
Okay,
I mean, seriously.
then that's the plan. Now, that means your plan's going to be different from my day class, because the day class didn't get that option. But they didn't miss so much on fall break as you did. Okay, so the test will be next week over chapter 2 only. We will have a separate test over chapter 3 only. I will open it on Halloween night.
Will we be done next week?
Yeah, because we're going to be done next week. I can finish
Oh,
it.
so after the test, next week, we're gonna have class?
You're going to have class. I normally don't do that, but what I'm going to do is I'll give you the test on Halloween night, but it's going to be open for 3 days. So it'll be open October 31st, November 1st, November 2nd. Any time in that 3 days, I will give you 2 hours to do the test, and it'll be over chapter 3 only, and you'll do it out of class. Your exam 2 score is going to be the average of the chapter 2 test and chapter 3 test. Okay? I will average those together as if they were one test. So what we're doing is we're doing a half test and another half test. Everybody understand? Okay, now the question is, do we come on Halloween night? Well, with as many parents as there are in here, if you tell my daytime class, I'll shoot all of you. Because they're going to be mad because somebody got a day off.
Don't give them access to this integrity lecture.
Well, they don't get this integrity lecture. They don't get your integrities, and you don't get theirs unless I don't get to record in both classes. So their test is going to be as scheduled, and they'll have to have class on Halloween, but they're not coming at night, and you guys work. So I'm going to give you Halloween night off, but the trade-off is you're going to have to go ahead and watch the chapter 4 lesson that I'll post before you get here the next Monday night. Okay? It'll be a Nearpod lesson. I'll make sure that you got the notes. I'll go ahead and I'll actually probably record their lecture for you to have to go over it too. But the Nearpod really will probably get you started, okay? So you can have Halloween night off.
Thank
Okay.
you so much.
I've got a grandchild too. I don't even get to have her on the 31st, but I know if I did get to have her on the 31st, I'd want to be there.
We've got parents in Bluff City and, Bulls Gap, and so we go to both and we take them and it's.
I know, and it's hard. It's hard.
It's a whole.
So that's our compromise. We do have tests next time. We will finish chapter 3 next time. We're going to finish chapter 3 as much as we can tonight. But then we will take Halloween night off as long as you agree that you have a take-home test and a lesson to preview before the next class. Fair enough?
Yes.
Okay.
Thank you.
You're welcome. I understand. Been there. Am there. Okay. Manufacturing example, then we're going to go on to the next section. Happy Ice Cream Cone Company makes cake cones and sugar cones, 2 different kinds of cones. They both have to be processed in the mixing department to make the dough, and then in the baking department to bake the dough, to make the ice cream cones. Manufacturing 1 batch of cake cones requires 1 hour in mixing and 2 hours in baking. Producing 1 batch of sugar cones requires 2 hours in mixing and 1 hour in baking. Each department is operated at most 12 hours a day. That information gives us enough information to come up with a system of inequalities. The number of units made are our variables, X and Y. X takes 1 hour in mixing and Y takes 2 hours. So 1X plus 2Y is going to have to be equal to or less than 12 hours. For the sugar cones, they take 2 hours in mixing, but 1 hour in baking. So we're going to also have 2x plus 1y is equal to or less than 12. Okay? The table helps you organize the equations. Since the amount of time in each department can't exceed 12 hours, we'll set each department's total number of hours to be less than or equal to 12. It is not possible, and this is not listed on this table, but this is a common sense requirement. It's not possible to make a negative number of either product. So X can't be anything but 0 or positive, and Y has to be 0 or positive. So from this first row, from the second row and the third row, we get these 2 equations. The mixing department is 1 for the X cones and 2 for the Y cones. It has to be equal to or less than 12. And remember that X is cake and Y is sugar cones. So 2 hours for the cake cones and 1 hour for the sugar cones has to also be equal to or less than 12 in the baking department. So your 2 variables are the number of sugar cones and the number of cake cones. X is the cake cones, Y is the sugar cones, as it says here. This is your system of equations for that problem. We need to graph that system of equations. Now, we've slowly and painstakingly graphed every one up to this point, so I'm going to actually skip over quite a bit of this. You're going to have to go back and fill in your notes on the graphing part, because we've graphed a lot, and if you've got sufficient time, I know you can do it. So ultimately, this is what our graph looks like. Okay? This is restricted to X and Y being greater than 0. It turns out that 0, 0 works in the blue equation, and it works in the red equation, because 0 in both cases is definitely equal to or less than 12. So this is our feasible region. Don't worry about what those 2 green points are just yet. Okay? That's our feasible region. So on the next slide, it says, using the graph from part B, Can 3 batches of cake cones and 2 batches of sugar cones be manufactured in one day? That means, is the point 3, 2 in the feasible region? Where is the point 3, 2? It's in the feasible region, so that is possible. Okay, the other question is, can they make 4 batches of cake cones and 6 batches of sugar cones in one day? And you almost shouldn't even have to answer that, because considering that one or the other of these is going to be doubled in both of the equations, you're going to exceed the potential amount for 12 hours. And the 0.46 does indeed fall completely outside the feasible region, so that's not possible. Okay? That's the end of that problem. Graphing the feasible region will tell you if certain solutions are possible or not. We haven't gone into the idea of optimizing yet. Optimizing is where can you maximize or minimize profit. So we haven't gone into something called an objective function. But we have applied systems of linear inequalities. So at this point, I'm actually going to